Okay. Hello. Can my screen be properly presented?
Yes, we can see it.
Okay. Hello. Thank you. Hello, everyone. My name is Junjie Chen. I'm right now a postdoc at the University of Hong Kong. I'm very glad to have this opportunity to present our recent work on markerless augmented reality for facility management, particularly that propose a spatial registration approach based on style transfer generated network. Here's the outline of the presentation. First, I will introduce some background information. Then in part 2 and part 3, I will respectively introduce the method we propose, and then how we can develop a prototype based on the method. And in part 4, we'll validate the method via a series of experiments. And finally, I will conclude the presentation with a few remarks. We all know that facility management is important because it not only because it can help us identify defects such as cracks, spalling, and many other potential safety issues, but also because it can help us ensure the utility or some mechanical equipment is operating properly. But it is also a demanding task because sometimes when we need some information related to the buildings to support our decision, to support our decision making, we'll find it difficult to retrieve those information. Or even if we can retrieve them from the CAD drawings, they're not intuitive enough. So that's where augmented reality can come in and help us by combine the cyberspace with the physical world that we can actually see in reality. So a core component of AR is spatial registration, and currently there are two approaches to address this problem. One is marker-based registration. I think the previous presenters have used this method. They use QR code to scan the code and register into a virtual model. And the second approach is some sort of infrastructure reliant approach. But however, these two approaches require tremendous efforts to set up or maintain the infrastructure and markers. So in light of the limitations, researchers have been trying to develop registration technology that does not require any external infrastructure, and which is called markerless registration. In the typical settings, a reality capture technology like laser scanner or photographs will be used to pre-map the environment. And then with the point cloud of the environment, we can do the registration. But nowadays, with the widely use of BIM, we started to wonder why, because BIM is a virtual representative of its physical counterpart. So it has all sorts of information we need to register. So why don't we just register the photo into the BIM directly? So, but in reality, that sounds promising, but there's obstacle to do that. And the key challenge is the cross-domain gap between BIM and photos. As you can see, if they are from the same domain, the SIF algorithm or some other algorithm can properly process the photos. But if they came from two different domains, it's hard for computers to process them. So our solution to address the challenge is, if it is so difficult to register two mutually distinct domains, why not just convert them to an identical domain? So here is our solution. Basically what we did is to train a machine learning model that can learn the style or texture from photos and then apply them to the bin render views. And here is some results. You can see after the style transfer, quite plausible images have been generated. And the synthetic photos not only look more real, but also it has narrowed the gap between the bin views and the photos. So, and after the style transfer technology is used to process a collection of bin views, and then after that we can create a reference bin, a reference database that can be used to register in later steps. So with the database, we now can implement the spatial registration. Suppose we've got a query images, the synthetic image most similar to the query image will be retrieved based on the similarity of some sort of global features. And after that, we can detect key point correspondences from the query images and the retrieved images, use algorithms like SIFT, and then as we can know the 3D world coordinates of all the key points from the bin, so we can get a bunch of 2D and 3D correspondences. With that, it is straightforward to use to solve a classic photogrammetric problem to get a camera pose. So the above is our proposed registration approach, and then we apply the approach to develop a prototype mobile app. And here are some technical details. The first thing worth mentioning is that in order to maintain the texture of the bin model, we have used a middleware called SynLab Composer to process the model and then import it to Unity 3D. And another thing is that what we want to do is to develop a standalone application in this stage. So we have no servers in the backends. Therefore, we choose to store the reference data in locally on the mobile phone. And the approach was evaluated by a few experiments in a campus building. And first, we have implemented the visual Turing test. So what we did is to outsource the synthetic photo and the real photos to some workers to let them rate if the images is real. So as you can see, around 50% of the samples have been confused, have been mistaken as real photos. So we can say that the style transfer has really generated some plausible images that can confuse human beings. And also, of course, the machine readability is also improved. This slide shows the results of image retrieval, and we found that compared with features such as HOG and others, the retrieval based on EHD can achieve higher accuracy. And of course, the camera pose and estimated by our approach is also evaluated. And the localization error of the estimated camera surpass or is comparable to the state of the art. And also in terms of the registration successful rate, we have reached a success rate of more than 77%. And finally, we have also demonstrated how the developed app can be used to support actual facility management. So here you can see, after opening our app, you are directed to an initial interface where you can take a photo, and based on the photo, our proposed algorithm will be implemented to register your device into the BIM model. And finally, you can use the device to support the decision making and so on, including see the hidden NEP. And finally, here's the conclusions. In this study, we propose a markerless spatial registration approach enabled by style transfer. It was found that style transfer can effectively adjust the cross-domain gap. With the style transfer BIM wheels, solid registration performance has been achieved. An app has been developed to validate our concept. In the meantime, future works are also suggested to improve the robustness of the approach and also to adjust the challenges posed by self-similarity of architectural design. That's the end of this presentation. I appreciate any questions. Thank you very much.